ABCACUS AB Unit 4 Day 10 warm-up. One last little review warm-up before our test coming up soon. There's 5 problems here. Pause the video, do the problems yourself first, and then I'll show you how to do them and show you the kind of work I need to see to get full credit. Now, number 2, you got to do it the long way. Number 2 is technically not a derivative, or even if it was a derivative that you could really probably be able to do yet. On number 3, I want you to also use L'Hopital's rule in addition to another method, not L'Hopital's rule. Okay. Okay, assuming you've tried these, slope of the secant line. Secant line is when you have a curve and you connect 2 points. That's the secant line. So we're trying to find the slope between those. So the slope of the secant line is f5 minus f3 over 5 minus 3. So this is really good to show because this shows me that you know what you're doing. Make little mistakes after that, that's less. If you don't show this and you make mistakes, then I might not really see that you know what you're doing. 5 times 5 is 25 times 5 is 125 plus 5 is 130 minus 27 plus 3 is 30 over 5 minus 3 is 100 over 2 is 50. Now, what if I asked you for the slope of the tangent line or the normal line? Well, the slope of the tangent line just would be the derivative with, at whatever point. You'd have to find the derivative, which would be 3x squared plus 1, right? And the slope of the normal line is the slope of the tangent line, negative reciprocal, because they're perpendicular. Could also ask you for the equation of the secant line, tangent line, or normal line. Okay. Number 2, if you plug 0 in, you're going to get 0 over 0. So this is an indeterminate form. You can't do L'Hopital's rule because you don't know what the function is. It does look like the definition derivative, and it's close, but there's some things that are wrong with it. So we're going to do it the long way. Now, this is the function, okay? And so we're going to go ahead and say, okay, well, it equals the limit as h goes to 0. So you got to write this on each step until you actually finally take the limit after you get rid of the whole. So we're going to plug x in, which is just the function, and then we're going to plug x plus h in. Now put parentheses around the x plus h because it has to get all multiplied by 3, all over 2h. Now I'm going to think of the 2h's over 1. Now I'm going to go ahead and simplify this a little bit more. So we have 1 over 3x plus 2 minus 1 over 3x plus 3h plus 2 times the reciprocal 1 over 2h. Now, we need to get these together as a single fraction. So we got to give them least common denominators. And even though they look kind of common already, you need this whole thing over here, you need this whole thing over here. So we multiply top and bottom of this by 3x plus 2 and 3x plus 2. You can do this in your head if you want, or if you feel like you might make less mistakes, then write it out. So we're multiplying the top and bottom to get these to be the same. Okay, now the top is going to be 3x plus 3h plus 2. This one's going to get a minus distributed to it, and it's going to be all over one big common denominator. Don't multiply the bottom out. That would not be helpful for you at all. Now, the whole point of this is that hopefully there's a whole, which we know is supposed to be at h. So we got to be able to factor an h out of everything on the top. And if there's anything that doesn't have h's in it, then hopefully it's going to go away. Because if it doesn't, something's wrong. 3x minus 3x. 2 minus 2. Only thing left has an h in it. So that's, you know what should happen, right? Yeah. There's the whole. Cancel it out. We plug 0 back in. We get 3 over 2, 3x plus 2, 3x plus 2. And that could be your answer. Or you could write a little more compact if you want. 3 over 2, 3x plus 2 squared. Sure, okay. I mean, if you really want, you could FOIL that out. I don't think I would, but whatever. You're going to do a problem like that. Okay, so be ready for it. Hopefully, you've got a lot of practice. It's kind of a feat of algebra tediness. Okay, if we plug 4 in, 16 plus 4 is 20 minus 20 is 0 over 0. So if this is an indeterminate form, we could factor the whole out like we just did in number 2, but this time it's a lot simpler. So, I mean, you're trying to get x minus 4 out of the top and bottom. So, I mean, you could just start with that. It should make it easier to factor the normal. And then it would be plus 5. That makes sense. There's the whole. Plug 4 back in. The answer is 9. I'm also going to ask you to do this with L'Hopital's rule, which you have to show this first in order to be allowed to use L'Hopital's rule. And so it's going to equal the limit as x approaches 4, still have the limit of the derivative of the top over the derivative of the bottom. Plug 4 back in, get the answer, 9, do the same, that's good. Number 4, we're going to negative infinity, which gets raised to the 4th power, becomes positive, square root of it is positive, so we have some kind of positive infinity on top. And negative gets squared to make positive, but there's an extra negative, so it's going to be negative infinity on the bottom. These are the dominant terms, okay? We better get a negative answer. That's one thing. Now, if you did this, it'd be 3x squared, and these have the same degrees, so it's just going to be the ratio of their coefficients. 3 over negative 6 is negative 1/2. Now, technically, usually we put absolute values around this, but because it's being squared, that already ensures it's going to be positive. The absolute values are here to ensure it comes out positive no matter what x is. In this case, it is going to be positive no matter what x is. So, anyways, there you go. That's your answer. You could do L'Hopital's rule on that, but it involves stuff that I haven't really technically showed you in lessons yet. Rectilinear motion. Now, this one isn't gravity. This isn't necessarily vertical, or it can be horizontal. But velocity. Well, velocity is the derivative of position, so that's 3t squared minus 6t, and then we can plug 3 into it, and we get 3 times 3 squared minus 6 times 3. It's going to be 27 minus 18 equals 9. Okay, now b bar right here, or average velocity, is going to be the slope of the position curve. It's the average slope. It's the slope of a secant. Like if you have your position curve, the slope of this is velocity. If you want the average of all the slopes between 3 and 4, then you want the average of all the infinite little tangent lines slopes. And the nice thing is, it's just going to be the slope of the secant line. So it's going to be S4 minus S3 over 4 minus 3. And so that's going to give you, if you plug 4 in here, you get 64 minus 48 is 18, plus 1 is 19, minus 3, 27, minus 27, 0 is 1. Show work on your paper if you don't feel comfortable. In fact, I already made a mistake, so I guess I should. I'm going to figure out S4s real quick. So 4 cubed, that's 3 times 4 squared, plus 1. Be 64 minus 48 plus 1 is going to be 16 plus 1 is 17. Okay. And that's 3 is going to be 3 cubed minus 3 times 3 squared plus 1 is 27 minus 27 plus 1 is 1. So it's going to be 16 over 1, and the final answer is 16. Okay. Mistake people are going to make. Some people are going to say, oh, well, V averages, I'm just going to add the velocities at the ends and do a simple average divided by 2. Nope, that's nothing. Some people are going to do this. They're going to say V average equals V4 minus V3 over 4 minus 3. But now you're doing the slope of the velocity curve, which is not V average. That equals the average acceleration, which you weren't asked for, unless you were. So be careful. Make sure you use the right one. And that's it. Be ready for your test.